Hi friends, welcome back to my channel on mathematical statistics and statistical softwares. In this video, I will explain brief introduction to probability and what are the basic concepts and what are the some notations and types and with examples. Now we can see why learn probability. Probability means we all know about what probability means chances, chance of occurrences, chance of occurrences. Why learn probability means see nothing in life is certain. In everything we do, we guess the chances of a successful outcomes from business to medicine or whether see everything is comes under probability because we need anything to accept, anything we need to expect. For example, we can forecast today whether it will be rain or sunny. We can some person says that 50% rainy season, 50% rain, 50% sunny. How we can say this is chances. If we flip the coin, 0.5% is head, 0.5 is tail. This is chance of occurrences. Now we can see a probability provides a quantitative description. Quantitative descriptions means numerical. It cannot give qualitative. It will give quantitative description of the chances of likelihood associated with the various outcomes. Now we can see it provides a bridge between descriptive statistics and inferential statistics. We all are descriptive statistics and inferential statistics we discussed before, some definitions and some types, all things. See, this is by observing this diagram you can understand. Population means complete information, sample means part of population. Now we can see how we can draw samples from population means by assuming probability. By assuming probability, we draw samples from population to sample. Then we can apply some tests on sample. Then we can, by using statistics, we can say that this sample is suitable for that population. Like this. This is three points for why we learn probability. Now we can go to probabilistic versus statistical reason. What is the difference between probability and statistical reasoning? See, suppose I know exactly the proportions of a car makes in India. Then I can find the probability that the first car I see in the street is a Ford. Is a Ford. This is probabilistic reasoning. Yeah, this is probabilistic. As I know the population and predict the samples. But if you go to the statistical reasoning, then what will happen? Now suppose that I don't know the proportion of car makes in India, but would like to estimate them. I observe a random sample. This is important. By observing samples, we can estimate you can estimate the samples of cars in the street, and then I have an estimate of the proportions of the population. This is statistical reason. Statistical reasoning based on population and sample. Probability is based on chance of occurrences. Now we can see experiment. Probability always start with some experiments. Without experiment, probability is nothing. See, an experiment in any activity from which results are obtained. A random experiment is one in which the outcomes or results cannot be predicted with certainty. Before we cannot do anything. First we can apply any experiment, then only we can see like this. These are examples. Flip a coin 3 times, roll a die, draw a simple random sampling of a size 50 from a population. These all are the examples of experiments. Now we can see some basic concepts in probability. There are mainly lot of topics are there, but we can discuss some topics. See, before going to the definition, first we can see the some basic concepts. Number one is random experiment. Before that, before slide we can see what is experiment. Without experiment, statistics is a probability, we cannot do anything. See, what is random experiment? An experiment is said to be an random experiment if when conducted repeatedly under identical and homogeneous, this is important, identical and homogeneous conditions, the result is not unique but may be any one of the various possible outcomes. These are the definitions. In other words, it will satisfy 3 points, that is an experiment whose outcomes cannot be predicted in advance is called a random experiment. For instance, we can take one example. If a fire can is tossed 3 times, it will pos it is possible to enumerate all the possible eight sequences. Means 3 times means 2 cube equal to 8. It will come like that: head, head, trail, head. Like this you get 8 outcomes. And but it's not possible to predict which sequence will be occur at any time. This is the one example of random experiment. Now we can see what is sample space. Sample space means number of possible outcomes. Means, for example, we can flip a coin 2 times, then you get 2 square equal to 4 sample space. For example, you can roll a dice 2 times, then you can get 6 square, 36 sample space. Like this. This is the now the set of, you can see what is the definition. The set of all possible outcomes of a random experiment is known as the sample space, and it is denoted by capital S. Each each outcome of a random experiment under consideration is called a sample points. Then how many points you are, like, see, for example, you have head, head trail, head trail, head. These we can consider these both are the sample points, like that. The totally of all sample points is called a sample space. The total points is called sample space. For example, sample space of a trial conducted by tossing a 3 coins. This is sample space. Head, head, trial, trial, head, trial, head. Like this, you can get 8 sample points. In the above experiment, it is simple to note that any one sequence of head and our trial, it is simple. So it is sample points are from this, then total sample space is 8. Now we can go to the what is trial and what is events. Performing a random experiment is called trial. Trial means we are conducting any experiment at one time is called trial, and outcomes are combinations of outcomes are termed as the events or classes. Any subset of the sample space is an event. Any subset of the sample space is an event. In other words, the set of sample points which satisfy the certain requirements is called an event. For example, we can see one example. For example, if a coin is tossed repeatedly, the result is not unique. Yes, if all at all times you are tossing coin, then result is not unique. Tossing of a coin is a random experiment, and getting a head or tail is an event. Now we can see what are the types of events. First, we can see what is exhaustive events. Exhaustive events. It is defined as total number of all possible outcomes of any trial. If you performing any experiment, then we can exist all possible outcomes, then it will be says that exhaustive events. In other words, if all possible outcomes of an experiment are taken into the consideration, then such events are called exhaustive events. We can take one example. When a coin is tossed 3 times, there are 8 exhaustive events, and when 2 dice are thrown, 36 exhaustive events. These are the definition of exhaustive events. Now we can see the what is favorable events. The number of outcomes of a random experiment which results in the happening of an event are termed as the cases favorable to the event. For example, in 3 tossing of a coin, the cases of favorable to the even that there are exactly 2 heads, that this is 3. We can see one example here. For getting at least 2 heads, is 4. Favorable means according to the condition it will become. Now we can see mutually exclusive events. Mutually exclusive is the most important definition. Mutually exclusive means no common points. For example, I am taking 2 sets, E1 and E2. It will be having no common points between E1 and E2, then we can say that this is mutually exclusive events. We can see definition. 2 or more events are said to be mutually exclusive if the happening of one of them prevents or precludes the happening of the all others in the same experiment. This is definition of mutual exclusive. No common points. Generally, we can say that there is no common points between the two sets, two or more sets. Then we can say that it is mutually exclusive. Here, we will take one example. Also, they will take E1 and E2. Then introduction of E1, E2. Always introduction in mutually exclusive is pi or 0. Now we can go to the complementary event. Complementary means, for example, I am saying 0.4 probability of a success is 0.4. Then probability of complement is 1 minus. This is chances. Probability of a complement not occurring, like that. Probability of a complement, it will be denoted by like this, 1 minus 0.4. It will come out 0.6. Now we can see the definition. The complement of an event A means non-occurrences of an event A and is denoted by A bar or A complement, or A complement given A bar contains those points of a sample space which do not belongs to A. In a tossing, this is all examples. By understanding this example, you can now we can see independent events. Events are said to be independent of each other if the happening of any one of them is not affected by and does not affect the happening of other events. There is some quite difference between mutually exclusive events and independent events. In mutually exclusive, no common points, but in independent events, common points are there, but happening. It will be not happen in, for example, by observing example, you can understand. In testing an unbiased coin, unbiased means two different faces coin. The event of getting a head in the first toss is independent of a getting a head in the second and third subsequent throws. This is the simple example of independent events. Then we can, this is also by card example, by observing sampling examples, you can clear up with what is independent event. Now we can go to the equally likely cases and simple elementary events. First we can see what is equally likely cases. The events are said to be equally likely if the chance of happening each event is equal or same. See, by observing example you can understand. See, this is example A. Die is rolled, any face is as likely to come up as any other face. Hence, the six outcomes 1, 2, 3, 4, 5, 6 appearing up are equally likely, like this. Now I can see what is simple event. Simple event, also known as elementary event. An event which contains only a single sample point is called an elementary event or simple event. Example, tossing a die or getting a number 5 is called a simple events. Now we can see what is compound event. Two or more events occurring in the connection with each other, then the simulation occurring is called compound events. By observing examples you can understand. Now we can go to the definition of probability. This is actual definition of probability. The chance of a happening of an event when expressed in quantitatively is called probability. Quantitatively means numerical or possible to measure. The probability is defined in the following three ways: classical or mathematical or prior definitions, or empirical or relative or statistical definition, axiomatic definition. These three are the definitions of probability. Now we can see step by step. See, classical or mathematical definition of probability. This is the classical and mathematical definition of probability. This is the oldest and simplest. This is introduction about this definition. This is the formula. Now we can see this is the oldest and simplest definition of probability. This definition is based on the assumption that the outcome or result of an experiment are equally likely and mutually exclusive. According to the James Bernoulli, who was the first man to obtain a quantitative measure of uncertainty of if a random experiment results in n exhaustive and mutually exclusive and equally likely cases out which m are favorable to the happening of an event. The probability of occurrence of A is usually denoted by probability of A, and it is given by number of simple elements in a array divided by total number of simple elements. By observing some examples, you can understand. For example, I have one set 1, 2, 3, 4. Yeah, total number is 4. So total number of simple events are 4. I want to draw one element. For example, I drawn 2. Then chance of probability is 1 by 4, like this. See, this is also one example and some formal definition. Exact outcomes is unknown before conducting experiments. This is one point. All possible outcomes of experiments are unknown. Each outcome is equally likely. Experiments can be repeated under uniform conditions or identical conditions. Together, these conditions produce regularities of patterns in the outcomes. This is another definition of classical methods. Now we can see some points to remember about classical definition. The above definition of probability is widely used, but it cannot be applied under the following conditions. If it is not possible to enumerate all possible outcomes for an experiment, if the sample points are not mutually independent, that time we cannot apply classical definition. If the total number of outcomes are infinite, that time we cannot apply. If each and every outcome is not equally likely, this time also we cannot apply that classical definition. This is the some brief introduction about this. Now we can go to the examples of classical method. See, probability of two heads in two tosses of a coin is 1 by 4. Yeah, we know that. Probability of two heads in two tosses. For example, we get head only. Remaining all are different, so we get 1 point. See, probability to obtain 4 in a roll of a one die means 1. 1, 2, 3, 4, 5, 6 there, then we get 4 means 1 upon 6. Total of 4 when rolling 2 dice, that time we get 3 upon 3, 36. It will be, yes, this is also. If one randomly select individual from a large population of that is of males and of females, probability of male and female, if two individuals selected means 2 by 4, this is chance of probability. Probability of two females and one male if three individuals means 3 upon 8. Yes. Now we can go to the statistical definition of probability. This is the statistical definition of probability. If an experiment is performed repeatedly under essential and homogeneous and identical conditions, then the limiting value of the ratio of the number of times of event occur to the number of trials. By observing this definition, you can understand. See, when you can apply limit n tends to infinity, at that time you will reach number of trials. This is brief introduction about statistical definition of probability. This is also introduction about statistical definition. Now we can see axiomatic approach of probability. This is most important definition because we need these all 3 points for satisfying axiomatic probability. Probability is defined in is a real and non-negative means probability value always lies between 0 and 1 and to start with 0 and end with 1. It is always positive, no negative. If A1 up to An are mutually exclusive events, then the probability of the occurrence of either A1 or A to An is denoted by union, then union equal to summation. This is axiomatic definition of probability. Now we seen three methods: classical method, statistical method, and axiomatic approach method. Now we which method we can select, that is important. See, whenever it is possible to apply it, use the classical method. This is one point. When dealing with economic activity, the classical method often cannot be used. Obtain data and use the relative frequency method means statistical method. In neither of these is possible, use the subjective method if it is weak method, but if your judgments are sound. These subjective probabilities can be based in the coordination with economic theory and more soundly based probabilities. Now we can see some examples of probability. For example, toss a fire coin twice. What is the probability of observing at least one head? I can toss one coin two times means I get head. Next time I get trail. This is one chance. Then I head head. This is chance to trail head. This is chance 3 head trail trail. This is chance 3. Now our condition is observing at least one head. One head means here we get one head, here we get one head, here. So probability is 3 upon 8. See, first coin, then second coin. These all are the possibilities. 1 by 4 upon 1 upon 4, 1 upon 1 upon 4. When you get at least one head, that time you get these three. These three you get. By summation you get 3 upon 4. Now you can go to the example 2. A bowl contains 3M and MS. One red and one blue and one is green. A child is selected 2M and MS at random. What is the probability that at least one red is? By observing this you can understand. See, this is blue, this is green, this is red. In first chance I drawn blue and green. Second, red green, blue green. Then we can see probabilities: red green, blue red, green blue, green red. So total is 8. At least one red is, by observing we can say that at least one red is 4 by 4 chances. So 4 upon 6 is 2 by 3. Now we can see the dice example. The sample space of throwing a pair of dice is 36. 6 square is 36. Now we can see some examples. Dice add to 3 means 1 to 2 1 possibility, that is 2 upon 36. Dice add to 6 means 1 5 6, 2 4 6, 3 3, 4 2 5 1 is 5 by 3. Red die shows 1 means 1 1 1 2 1 3. Here you get 6 upon 36. Green die shows 1 means 1 1 2 1 3 1 4 1 5 1 6 1. Here also you get 6 upon 36. Thank you for watching. If you are first time viewing my videos, please subscribe my videos and share to your friends. Thank you.